Okay, so we're going to end this year with merging 4.1 and 4.2 together, okay? So this is going to be called Unit 4, okay? So Unit 4, we're going to we'll just have different sections, but we will not have two separate systems and matrices because we don't have that kind of time. Got it? All right, so merging together. In order to merge, we need to make sure we understand some basic foundational Algebra 1 stuff, okay? Starting off with, if given these equations, can you identify key features of a linear equation? Okay, so looking at number 1, if you can identify the slope and y-intercept, please raise your hand. Okay, given number 1, if you can identify the slope and y-intercept. All right, someone with their hand up, please tell me, what is my slope? It is 2 over 1. Okay, someone with their hand up, please tell me what my y-intercept is. -1. Okay, how do I know that? Because this is in slope-intercept form, right? That means that the coefficient with the coefficient with x, that is my slope. The constant is my y-intercept. Yes? Yeah. All right. Now, are all linear functions given in that format? No. When they're not given in that format, in order to identify my slope and my y-intercept without a calculator, I have to get it into that format, correct? So on number 2, what are the steps I take to get it in that format?
Start off by subtracting 2x.
Perfect. I'm going to start off by subtracting 2x. And I'm going to be left with 3y equals -2x plus 6. Then what do? Divide by 3. So now my y is by itself. Can I identify my slope and y-intercept? Yes. What is my slope? -2/3. What is my y-intercept? It's at 2. Okay. That is what you spent 180 days doing pretty much in Algebra 1, or you should have. Okay. That's what you should have spent most of your time doing. That is the foundation of it all. Okay. All right. So we're going to keep going. Our 4.1 is where we're starting, and it's talking about solving systems using tables and graphs. Before we do that, I want to make sure that we are still okay with slope of a line. What is the slope? What does it mean? Okay. Okay. What is the slope of a line? Well, the slope of a line is your rate of change, right? It is the change in your y divided by your change in your x, right? How many of you have chemistry or physics? Okay. Have y'all seen the triangle being represented?
With the V and the icon.
So the triangle means what?
Delta.
Delta is called our delta, right? So shorthand way of writing change in something would be delta y over delta x. Yes? All right. So our change in y over our change in x. If you're given 2 points, so if I'm giving x1, y1, and x2, y2, there is a formula also I can use to find slope, correct? There we go. y2 minus y1 over x2 minus x1. Rings a bell? Yeah. Okay. Then when it came all down to it, your teachers told you a nifty little way from a graph how to find your slope. And what was the way your teachers told you? Your rise over your run. Okay. Did any of your teachers ever say fall over crawl? Okay. Oh, okay. All right. Fall over crawl. Sometimes people forget that you also need to go the opposite way, right? So you can fall and then you can crawl also. All right. In a typical form, all of this is what we call our slope, our m, correct? All right, next, y-intercept. What is your y-intercept of a line? There we go. Where we cross the y-axis, where I'm gonna just write it. That looks like if. Maybe I should write the line. Where the line crosses the y-axis. Erase. Okay. In general, it also means that when this happens, that means your x equals 0, right? It's when your x equals 0. That's why it's written as 0, comma, your b value, right? 0, comma, some unknown value. All right, there are 3 forms for your linear equation, okay? The first one that you learn is called your, that's your slope intercept, and that's your y equals mx plus b, right? M equals your slope, and b equals your y-intercept. Agree? Okay, the other form that you may have seen but may not like remember and keep in your brain is called your standard form. That's ax plus by equals c. Does that look familiar? Okay, so for this format, a is always positive. It's going to always be positive, and a and b are integers. What is an integer? A number. Good job. There you go. Okay, a negative or a positive whole number. Does that make sense? It's a positive whole number and it's opposite. Okay, that is what an integer is. Okay, that means it's not a decimal, it's not a fraction for A and B. All right, last but not least is our point slope form. Point slope literally means that you've been given a point in your slope. And they're opposites. So in point slope, we have y minus y1 equals m times x minus x1, where x1 and y1 is your given point. Does that ring a little bit of a bell? Very tiny bell, we'll take it. Ding, ding, ding.
I used to hate doing that now.
Your K, that's variation. When we did variance. Yeah. Or you're talking about quadratics, your H and your K. Yeah, you're talking about quadratics. Your vertex, H and K is your vertex of your quadratic. Yeah. All right, now, how does this all come together? Well, here are our key concepts. We're going to talk about a system. A system is when you have more than one function that you're analyzing or being graphed at the same time, right? So you can have a system with a linear and a quadratic. You have a system with 2 linears. You can have a system with 3 linears, okay? But a system is when you have more than one function interacting and you want to make a conclusion about what's happening. Does that make sense? All right, so if we look right here, we have intersecting lines, okay? This is an example of a system that has one solution. We call it consistent and independent, okay? So this is a consistent and independent system, okay? Now, how can we identify that from an equation? What does that mean for our slope and intercept? When 2 lines are intersecting, that means that they have different slopes, but possibly the same y-intercept. Okay, it doesn't have to be the same, but the y-intercept could be the point where they intersect, right? We can start at the same, but we grow differently. Does that make sense? Okay, what's wrong? Oh, I'm sorry. All right, coinciding lines. Coinciding, that's a word from geometry. Coinciding is when 2 lines overlap. Does that ring a bell? So notice how up here I had a blue and a red, and when they overlap, what did they make? Purple, right? That throwing in a little art there. See that? Yeah, no? Okay. So coinciding lines are infinitely many solutions. That's because when you simplify them, they're going to end up overlapping. They're going to be the exact same thing. So what that means in terms of a system, and in terms of their slope and their y-intercept, they have the same slope and y-intercept after simplifying. Okay, so you're gonna have the same slope and y-intercept after simplifying. Okay, and we call that a consistent independent system. Lastly, we have parallel lines. So parallel lines we learned will never do what? They will never touch, right? And that's because they have this same slope, but different y-intercepts. Okay, so parallel lines are going to have the same slope, but different y-intercepts. That means we're traveling along at the same rate, but we did not start at the same time. Does that make sense? All right, so you have to be able to identify whether you have a consistent or inconsistent system. And if it's consistent, is it independent or dependent? Okay, got it? The second one says same slope and y-intercept after simplifying.
And the last one says
Same slope, but different y-intercept. You're welcome. So independent means that you have one solution. So independent means there's one solution and they are intersecting. Dependent means that they are overlapping, they are coinciding, and you have infinite amount of solutions. Okay, that means I can plug in any number and it's going to work for the problem. Okay. All right, so we either are going to intersect, coincide, or parallel. Intersect, coincide, or parallel. That's all your linear systems are going to do. Coincides when they slap on top of each other. Yeah. All right. Now we're going to talk about looking at a system and determining its results from a table. Okay. A lot of times we look at a table like, oh no, I need a calculator. No, before you even pick up a calculator, you want to analyze the table. Okay. What you're asking yourself, it says, what would be the solution to the system? So you're asking yourself, when are X and Y the same? That's all you're asking yourself when you're analyzing a table. So you have a equation here and you have an equation here. So this is y1 and this is y2. When I'm looking at them, I'm saying, I'm going to go through and see at any point, do these two tables have the same value? And do they? Yes. Where do they have the same value at? Right here, x equals 3 and y equals 1 here. X equals 3 and y equals 1 here. So guess what my solution is? 3, 1. That is my solution. That's it. Because there's only one solution, that means that this is a intersect. This is where they intersect. And because they intersect, then therefore it is independent. Okay.
What if there's multiple?
Okay.
If they were just constantly with the same.
If they had the same values, that means it would be a dependent and and we forgot consistent. So because they intersect at one point, it's consistent and it's independent. If every single value was the same, then this would be consistent and dependent. Does that make sense? If they had nothing in common, then it is a inconsistent system based on what's given to us. Does that make sense? So we only can go based off what it says, because it says using the table, right? And that's all we can do. All right. Okay. Any questions about reading a table to determine whether it's a solution or not?
No, it's pretty much.
Okay, cool. Now let's go to a graph. Okay. So what if I wanted to find graphically if it's a system, what type of system I have? Well, there are 4 steps that you follow. Step 1 is you want to solve for y. Okay. Which is why I said, do you remember, right? So we want to solve for y. We want to identify and plot our y-intercept, identify and use our slope, and then connect the points. Remember, our y-intercept is where we start. That's our B, our beginning, right? And then our slope is going to tell us where to go. That's our directions, our rise over our run, right? Rise over run. Okay, so we're going to do the red one first. So for the red, we have negative 3x plus 2y equals 8. What is the first step I need to do to get y by itself? I'm going to add 3x. Agreed? So we're left with 2y equals 3x plus 8. After I add 3x, what do I need to do? Divide by 2. After we divide by 2, we get that our first y equals 3/2 plus 4. Yes? So when I plot this, I'm going to begin at my y-intercept, and I'm going to rise 3 in, run 2. So I start at 4, rise 3, 1, 2, 3, run 2. Because my y-intercept is 4. Okay? I'm going to go down. So this is where that fall and crawl comes in. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Now I've been asked, how do you know if you're going the wrong direction? It won't make a line. Okay, so if you go the wrong direction, when you go down, you will not make a line. Pretend that this is the straightest line you've ever seen, and that I'm going through every single point just fine. All right, now I'm going to do the same thing that I did for the red for the blue. Make sense? All right, what do I need to move first on the blue? X. I'm going to subtract x. So when I subtract x, I'm left with 2y equals negative x minus 8. Then what do I need to do? Divide by 2. Notice when you divide, you're dividing all terms, okay? So we end up with our y2 is going to be negative 1/2 x minus 4. So we know that our y-intercept is negative 4, and our slope is going to be negative 1/2. So I'm going to go to negative 4. I'm going to go up 1, but this time instead of going to the right, I'm going to go to the left. Up 1 and to the left. Up 1 and to the left. Yes. So when you're crawling, rise, run, if you're going to rise first and it's negative, that means you got to go to the left. Because one of the values have to be heading towards negative values. Does that make sense? So if my y's are heading towards positive, then my negatives have to be my x's have to be heading towards the negative. Okay. Your solution is where the two intersect. Oh, that is not even going to be. That wasn't even going to try. Okay. Your intersect is where they meet. So where do we meet?
Negative 4, negative 2.
Negative 4, negative 2. So the solution here is negative 4, negative 2. And therefore, this is a consistent and independent solution. Does that make sense? So this is consistent, and independent. Okay. How do you feel about graphing linears and finding whether they intersect or not?
Feel better now.
Feel better now? Okay. The other thing is right off the back, I can tell that it's consistent and independent because the slopes are different, right? And that's the number one thing. Are the slopes different? Yeah. Yes. If the slopes are different, then I'm going to have a intersection, right? If the slopes were the same, then it was either going to be parallel or coinciding and overlapping. Okay. Yes, we can do this. Questions, comments, concerns about example 2. All right, next we're going to talk about real world examples and creating our own equations from a problem. So here we have a biology example. The diagram shows the birth lengths of growing rates of 2 species of sharks. Look how happy they are to be doing this problem with you. Okay, the growth rates stay the same. At what age would a spiny dogfish and a Greenland shark be the same length? So we're trying to figure out when they're going to intersect. Okay. When numbers get larger or we're dealing with decimals, sometimes it becomes more complicated to just graph on our own. Okay. So this example is going to be one where we talk about using the calculator to find their point of intersection. Cool. There should be calculators on your desk. If not, grab some. All right. So the first thing we want to do is establish our equation. So for the Greenland shark, we're going to let this be our y1. In order to write this, we need to write it in a slope format, in a slope intercept. So our goal is to write it as y equals mx plus b. So looking at the Greenland, what would be the slope of this shark? It would be 0.75. The key thing is remember that slope is the same thing as your what? Your rate, right? When we think of slope, we should automatically think rate. Change in what over change in what, right? So we know that its slope is 0.75. And its y-intercept is your y-intercept is where do you start? What is your beginning? So you should think about where do you start? Well, birth, right? Is where it starts. And so therefore our y-intercept is going to be 37. So this was our M and this was our B. For our Y2, our dogfish shark here, what is its equation going to be? 1.5x and plus 22. So now we're going to go to our handy dandy calculator. And it wants to know, when will they be the same length, right? So that's our question. When will they be the same length? So in the calculator, I'm going to reset my calculator because plus 712, don't know what was in there. And then I'm going to input it. So go ahead and input. All right, so we're going to go to y equals, and I'm going to put in 0.75x. Uh-oh. My x in that. Why does it keep doing that? X plus 37. Did I type it wrong? And we get 1.5x plus 22. All right, so we're going to hit graph. Notice when I hit graph, I see nothing. Oh no, I did something wrong. Okay, why don't I see anything?
Because it's right up there on top of the corner.
Yes, is my current setting for my window appropriate? No, it is not. So there is a trick though. When you're doing this, especially if it's two graphs, there is a feature on your zoom and you will press zoom and you're going to go down to 0 where it says zoom fit. And what this does is the calculator will do a little bit of work for you, okay? It will do a little bit of work for you to see if it can find where they're going to intersect. So when I hit zoom 0, it got me a little closer, but do I still see it? No. So I know that at this point, I'm going to have to change some numbers. The beauty about zoom 0 is that when that happens and I click on window, it's already increased my Y values, but maybe I need to increase my X values, right? So right now my X is at 10. I don't know. I'm gonna go up to 50. Don't know why. It just sounds like a good number. I'm gonna hit graph. I'm like, okay. I see a little action.
100.
I didn't see enough action.
Okay, 75.
Okay. So my window, my Y's, I can make this -1. I hate when it has a lot of lines, so I always change my scales. You don't have to if it doesn't bother you. It bothers me. And I like to be at 0 if possible. So let's go. You said 100?
75.
75? Okay. Not 750. And I'll count by 5s. Let's see. Did it get me a little better? A little better of a window? Boom. Oh, look at that.
50, is it, did you put 50 or 5?
I put 50. So my window settings that worked. You just gotta be patient with it.
Mine didn't do that.
I'm at -150 and I'm counting by 5s. I'm at 0, 75, and I'm counting by 5s.
That's the thing. Oh, the max. You put 50.
All right. So I can see this intersect. After you've done this, to find your intersect, you're literally gonna press second trace. When you press second trace, what do you see?
Intersect.
It says intersect. So when I press second trace, it says you want your intersect. I'm like, yeah. Press 5. And this is the magic thing. You're going to press enter 3 times. Okay.
Enter.
Oh, yeah. 3 times. Here we go. 1, 2, 3. And it says, here's your intersection. Your intersection is at x equals 20, y equals 52. Yes, it's asking you. You really want me to tell you? Yeah. It's like, you want me to look at this line? You want me to look at this line? And you want me to guess? Yes. Okay. All right. So you didn't hit intersect. You must have hit 0. Oh, you can't, you have to be able to see the intersection. That's why we talk about changing the window. Yes. All right. Okay. Yes. So at what point will they end up meeting?
And X20, Y52.
Okay. Does that make sense? All right. I'm going to go to the next page so you can see where that's written at. Or we can write it. So it says, what does the point represent? So we noticed that, where did they intersect? At 20 and 52. Okay. I'm supposed to point out to you that you also can use Desmos to graph this. Okay. You can do the same thing on handy dandy Desmos, right? Okay. So yeah. So then what does it mean? So what does 20 and 52 means in terms of this problem? So what does 20 represent? 20 what? 20 is our years, right? Does that make sense? What does the point represent? It says at age 20, right? They both will be. Because what does your X represent? How old they are, the age of the shark. 52. Okay, so let's go back to growth rate. I'm glad you pointed that out. So your growth rate is your centimeters per year, right? So centimeters is your Y, year is your X. Remember, your rate, your slope is your change in Y over your change in X. So for this problem, our change in our Y over our change in our X equals the change in our centimeters over the change in our years. That's what our X and Y axis represent. Does that make sense? So if we got that our X is 20, that's 20 years. And we got that our Y is 52, that is 52 centimeters. So when you're answering a real world problem in a sentence, you're saying at age 20, they both will be 52 centimeters. Yes? Cool. All right. Now it says, I meant for the answer to be blocked out. You don't see it, but pretend that you don't see that. Nothing, exactly. Good job. All right, so it says, to further use our data information and ask after 20 years, what would be the length of the two sharks? Okay, we're going to go over the two ways of analyzing this. So using your calculator, way number 1 is simply to go to your table and scroll to 25. Does that make sense? Okay, I'm going to go to the table and I could scroll to 25. Boom, 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 boom. I'm almost there. My computer just runs a little slow. All right, so when I get there, bam, what are their lengths at the age of 25? 55.75 and 59.5. Yes? Okay, that's option number 1. Option number 2 is to also just simply change your table settings, okay? Because 25 isn't bad to scroll to, but what if it asks you for 100? Is that as easy to scroll to? No. So what you can do is change your table settings so that you can input whatever value you need. In order to change your table settings, you're going to press second window. And you see how it says auto? We want to switch it to ask. What this does is it clears out our table and allows us to put in the values we want. Does that make sense? So now when I go back to the table, it's going to be blank. And it's all right. I want to know how big they'll be in 25 years. I want to know how big they'll be in 100 years. I want to know how big they'll be in 1,000 years, okay? It allows you to put in whatever values you want and analyze it from there. Create your own version of the table you want, okay? This is also good when you have fractions and or decimals. Yes. You also could do it manually and plugging in your X value, 100%. Okay. All right, but how do we feel about using the calculator? Good. Doable? Yes, and 55.75. Because it asks for both of their measurements. Okay. All right. The last question is asking about analyzing when one is bigger than the other. Okay. When you're talking about in terms of a graph, and you're describing when is something bigger than the other, you're looking at when is one function above the other function. Does that make sense? That is what you're analyzing. So our Y1, that's our green fish, right? Is that what they get? Yeah. Our green fish is our Y1. Our red line here is our spiny. Okay. The question is asking, when is your dogfish longer than your Greenland shark? So it's after they intersect, right? After they intersect, what does the red line do? It increases infinitely more, right? And it's above. So it would be after 20 years, which is why this says after 20 years, that's when my Greenland fish is bigger than my dog shark. Okay. All you're doing is looking at the graph and saying, when is one function above the other? Could you also look at the table and see when the values change?
Yeah.
Yes. But visually, you're just looking at when is it above the other. All right. Okay. How do we feel about part 3?
I liked it, even though I wasn't writing it, I liked it.
Okay.
So simple and easy.
Good.
I'm really watching it.
Okay.
Because
All right.
I don't have a paper on it.
So the plan for tomorrow is we're going to do part 4. Okay. So tomorrow we will do part 4. You will have time to do your exit ticket and to start on your classwork.
Are we doing
Okay.
it? Are you doing
And that will be it.
it?